Hello, I am Shane Brinkman Davis Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. We're going to take a pause in the arc we've been on, the 5 essential elements of modular software design. Don't worry, we'll get back to the last 2, implementation and connection, coming up shortly. But there was an interesting conversation that happened yesterday in my day job that I think is really relevant to our conversation here. We were discussing the configuration of our CI/CD pipeline, where we have a lot of tests. We've got end-to-end tests, we've got unit tests, we even have has the interface change validation tests. We have a lot of stuff in our CI/CD pipeline. And the comment came up that we should prioritize correctness over speed. In this case, it was referring to the speed of the CI/CD pipeline. But in general, I think you can think of that as development speed. Now, that seems, of course, eminently reasonable. So let me just add a little bit more color to what we're dealing with here. So we have a set of tests that are end-to-end tests were running really slow. They were getting upwards towards an hour. And we have since done some improvements. So now they're down to maybe 15 minutes. We also have some unit tests that take almost as long. And these tests all run in parallel. We're also discussing about whether or not these tests should be running first when we merge them into dev, and then again when we're merging them into stage. So that was a separate conversation. I think there's some nuance there, but it probably doesn't matter that much because the merging into stage doesn't happen that often. But the merge into dev is a bit of a problem because the nature of the modern Git development flow is that if you got a team working on multiple different things at once, you'll have many different PRs stacked up, ready to go, that need to get code reviewed and then merged into development. Now, each time the PR gets created, it's going to run all these tests. And then, and even anytime that PR changes, it needs to rerun all those tests. And when you've got several PRs backed up, what happens is whoever's doing the review will review a PR, accept it, merge it in development, and then all of the other pending PRs need to get updated to what was just merged and developed, and then that will trigger rerunning all of these tests. And if you're a person trying to approve multiple PRs, all of a sudden you're in a pinch because you're going to approve a PR, merge it and develop. You're going to go to the next PR, say update from develop. Then you have to wait. And previously you had to wait like 40 minutes. Now it's 15, 20 minutes, but you're just basically twiddling your thumbs while you're waiting 20 minutes. And that's just if you have to do 2 PRs. But if you've got 5 PRs you got to get through, all of a sudden like your afternoon shot waiting for slow PRs to happen. And this moves to a slightly broader observation on this project. We also have Git-commit hooks, which our Git-commit hooks basically involve TypeScript validations, making sure all the TypeScript compiles, and running prettier to make sure everything has a consistent formatting. And they take 30 to 60 seconds, I would say. So across the board, we've got a lot of things that slow down the development process for this goal of correctness. Now, back to that assertion. We should prioritize correctness over speed. And the person proposing this validated that speed mattered. They weren't completely just like correctness or bust, but prioritize correctness over speed. And I wanted to suggest that as reasonable as that sounds, it's the wrong answer. And here's why. It sets a precedence. And it sets the wrong precedence. And it doesn't even achieve its own goal. When you're prioritizing correctness over speed, basically it says correctness always trumps speed. That's what it says. The first problem is there's no such thing as 100% correctness. And so if you just said the correctness always trumps speed, then you could go down the dark path of chasing infinite correctness, which is not achievable, and always sacrificing speed to get there. And also, infinite correctness is not only impossible to achieve, it's also legitimately not necessary. No matter, even if you're talking about something that is mission critical and people's lives are on the line, there is a certain level of incorrectness which is still acceptable, that the product can still achieve its goals. It can still be safe for the people using it. And part of it is because you build in safeguards so that at runtime, even if there might be a little bit of incorrectness here or there, because at the end of the day, there are cosmic rays, and cosmic rays can flip bits in your computer, which can cause random stuff to happen. That's just the fact of life. So if you build in safeguards into your code such that it can recover from incorrectness, that is the right strategy if you need that really, 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 really high level of correctness. But back to the assertion, prioritizing correctness over speed. Now, this is a show about solving problems faster with software, so you can think that I might have a little bit of a problem with that. But here's the thing. There is a certain level of correctness, which is a requirement for any project. If you don't achieve that correctness, you have not achieved the goals of the project and you have failed. So I'm going to propose a slightly alternative way of stating this. And here is the statement. We want to achieve the required level of correctness as quickly as possible. So we want to achieve the requirements of the project as quickly as possible. That is the correct way to prioritize it. Requirements are hard set. And of course, what are the requirements for correctness? Because correctness is an infinite kind of thing, it has an unbounded amount of nuance, but you can very quickly set the baseline, what level of correctness is good, within a handful of minutes. You realize, is this a prototype? Is this a beta? Is this a first release to a small group of people? All the way up to, this is controlling a nuclear reactor, and if we screw up, lots of people are going to die. You can figure that out pretty quickly right at the beginning, and then you can nuance it from there to the details level that you need for the project. Now you've changed the equation. You've set a different precedence. Yes, we can have ongoing conversations about what the right level of correctness is, but then we can objectively say, what's the fastest way we can get to that level of correctness? And now you're back to optimizing something that's optimizable. You can optimize speed. You can't optimize correctness. Correctness is a requirement. It is not a thing that you want to make better and better and better. Now, of course, with optimizing speed, it has this, what's the word I'm looking for? It has this self-regulating factor in the sense that your goal is overall speed for the project, and it takes investment and time to improve your speed. And so you have to spend a little speed to gain a little speed. And if you're spending a little speed to gain a lot of speed, that's a good win. But there will be some point where you are spending more time trying to gain speed and you'll get less out of it. And so it has a self-regulating aspect in that at some point you should stop investing in speed and you just got to invest in getting the project done. It is self-regulating. So back to this project and these many levels of CI/CD for correctness. I'm just going to dive in and say how I think this should be done for this project. 1, Git-commit hooks should basically not exist. I think they're a terrible idea. I am somewhat sympathetic to you running prettier because having consistent code formatting it makes merging with other team members nice. However, I think the much better way to do that is with your editor, and make sure your editor format's on save, and then having people make sure that editors are configured correctly. And maybe that's a hard thing to do, and maybe Git commit hooks seems easier. But here's the thing. Git commits are important. And it is, from my perspective, important to do as many commits as possible throughout the day. Not that you're trying to maximize commits, but it should be as easy as possible to make commits because commits are your undo history for your code. You can get really good at using Git commits to debug changes, to understand what you're doing, particularly when you're making big refactors. Having many different checkpoints along the way is extremely powerful. And that's just for developing a current target, but even over the history of your entire project, more Git commit points is generally going to be better than less Git commit points, because you want to be able to roll back to meaningful points. And if you only have really big coarse points, you're not going to have a lot of fine-grained control over rolling back if you need to. It also can create really good visibility. If you've got really intentional, incremental Git commit hooks, you can go look at that one and say, all right, that's the one that made this little change. You look at it, you understand the change. But if you've got a whole bunch of changes all in one big Git commit, then it can be overwhelming to understand what any of them are doing individually. There's a whole lot of reasons why you want to let people commit a lot. And there's good reasons to squash commits too. I understand you don't want a lot of garbage commits in your history. You want good commit history, but a robust, full Git commit history is the goal, I would argue. And that's going to be probably a topic for a whole nother discussion at some future point. But the point is, you don't want to have friction for doing Git commits. And what are we getting really by checking on Git commits? And again, Prettier is a bit of a special case. And there's another, well, let's just dive into it right now. If the editor configurator is not enough, and again, the only thing is just trying to make your PRs a little easier. It isn't like essential that all your code base is formatted exactly the same, but it is useful to making PRs less of a pain. And so I think the editor configure path is perfectly reasonable. Like if you see some people, this one person keeps submitting stuff and their code is not formatted in the standard, using the standard code formatter, and it's causing PR problems, you'd know that pretty quick, and you would counsel them to say, oh, make sure your editor is configured correctly, so when you save, it saves it in the right format. Done. It's very self-regulating, and you don't need to have a Git commit hook to achieve that goal. But if you wanted to, I don't think it would be unreasonable to have it as part of your CI/CD once you've pushed, or even maybe it's part of your Git push. That might be okay too, to validate that all touched files match the required code formatting standard. I don't love that method because I think that, and here's where we're getting to the next step. So hold on to that for a minute. I do think you should be very strategic of where your gates are. Your gates that you have to meet a certain requirement in order to progress from the code production pipeline. Right now, we've got a gate on your Git commit hook. We've got a gate on all these things that need to happen at the PR time. And then we don't have any additional gates, although we have argued and now decided we are going to do it at the staging also, but that's essentially running the same gates again at staging. Having TypeScript run on your Git commit hook is, I think, ridiculously foolish. It's foolish in the sense that it is, one, you're going to be validating over and over and over and over again the same thing. So it's really inefficient, and it makes your Git commit hooks, your Git commits expensive, which you should not do. Strong opinion there. But even still, what does that gateway help with? If we are going to also require that you get over that same threshold in order to accept a PR, how does having a check that it can't get off your machine into the cloud, how does that threshold help when you're going to check it again before it gets merged with anyone else's code? In fact, I'd argue that's another thing you want to do. That's why I would argue you don't want to have actually a Git push hook either, is because you want to also have people get things off their machines as quick as possible, because your local machine is not backed up or may not be backed up well. It could be destroyed, it could be stolen, or people leave the company and what's on their machine may not get captured and put back into the fold. You want people pushing their stuff up into their personal branch so it doesn't interfere with anyone else, but you want people pushing stuff up ideally daily. Like at the end of the day, people should be pushing what they got. Again, you don't want to make friction for pushing it. And at the end of the day, it doesn't matter if what's in their personal branch in the cloud versus what's in their local branch. It doesn't matter if there's a difference from the point of view of TypeScript correctness. It does matter when we merge it with everybody else's code. And that's where you want the gate. You want the gate to be at the PR level when you go and merge into develop. So now we get to the PR question. Now, if you have a lot of really slow checks that causes the multiple PR problem that we discussed earlier, which is really the crux of this conversation, there's a couple things to think about there. One is investing the time to optimize those individual checks so they run reasonably quickly. But two, and I've not seen this done yet, but I'd like to play around with it. So I don't know if this is the right option. So I'll throw this out here for people to explore. And I would love to hear from you if you have tried this option. But you could perhaps have a two-tiered system. You can have a dev 1, dev 2. Let's come up with better names, but let's just call it development 1, development 2. And have it that we're going to merge everything into dev 2. The PR requirement is into dev 2. And you can only merge from dev 2 into dev 1. You can't merge anything else into dev 1. You can only merge from dev 2 to dev 1. You merge all your development branches into dev 2. Make the merges into dev 2 lightweight, like really lightweight. And mostly, a couple minutes each, and they all run in parallel. So the whole thing probably takes 3 or 4 minutes for the whole thing. That would be quite reasonable, quite doable, and you would catch most issues there. Like you run your TypeScript checks, those are reasonably fast. You run your unit tests and make sure those all run reasonably fast. But put things like your end-to-end tests on the dev 2 into dev 1 merge. So what happens here is that someone who's approving PRs into dev 2 has this relatively quick cycle. Like they merge it, and then they only have to wait a handful of minutes before they can merge the next one, That still seems a bit inefficient to me. So I would still like to sort of consider like how can we streamline that even further, and perhaps we make those optional at that stage. Like the checks will run, and if the person has other things to do, they can the person who's managing these PRs can wait from the finish, but they don't have to. Particularly if they're looking at it and going, I don't think these are even going to be affected by this change. This change is small. It doesn't even touch those tests. Don't think it's going to be a problem. Now we do want to run the tests because we don't want human fallibility to ultimately be the final gatekeeper, but we can get them all merged into dev 2 relatively quickly. And then when we create a PR from dev 2 to dev 1, then we run the robust set of tests. That way we can get a whole bunch of merges all in, and maybe just one merge in the day. And maybe, they finish those merges and then they let the dev make a PR and wait overnight. They could take a long time, potentially. I mean, I think that anything more than probably about 15 minutes is probably too much, because if you have to debug them, you're hosed if it's going to be longer than that. But at least if it's a gate, if it's a threshold, if it's an optional requirement, it can run longer. But that can run out of band. Like they can start that and then go about the rest of their day and come back at the end of the day and then complete the merge into dev 1. And now you have really the best of both worlds. And it's kind of algorithmic design at the end of the day. You want to do the costly things less frequently. So back to the top, our goal here is to solve problems faster with software. And so instead of prioritizing correctness over speed, what we're instead going to say is understand your requirements, which include correctness and a bunch of other things, and then optimize speed to achieve requirements. So I would love to hear your thoughts on this. This is a bit of a controversial issue. People have a lot of different opinions, but I do think that this is the right way to go. But as always, I don't have all the answers and I don't know everything, and I never will. I want to learn from you because I know there's a lot that I don't understand here, and there's probably scenarios I haven't thought of. So send me some comments. I'd love to hear from you. And once again, thank you for spending your valuable time with me. And remember, all problems are solvable with enough knowledge.